Jupiter's mass is 2.5 times that of all the other planets in the solar system combined. So massive that its barycenter with the Sun lies above the Sun's surface at 1.068 solar radii from the Sun's center. Jupiter is much larger than Earth and considerably less dense. It has 1,321 times the volume of the Earth, but only 318 times the mass. U-206, U-200. Jupiter's radius is about 1/10 the radius of the Sun, and its mass is 1,000th the mass of the Sun. As the densities of the two bodies are similar, a Jupiter mass, mj or mjup, is often used as a unit to describe masses of other objects, particularly extrasolar planets and brown dwarfs. For example, the extrasolar planet HD 209458b has a mass of 0.69 megajoules, while Kappa Andromedae b has a mass of 12.8 megajoules. Theoretical models indicate that if Jupiter had over 40% more mass, the interior would be so compressed that its volume would decrease despite the increasing amount of matter. For smaller changes in its mass, the radius would not change appreciably. As a result, Jupiter is thought to have about as large a diameter as a planet of its composition and evolutionary history can achieve. The process of further shrinkage with increasing mass would continue until appreciable stellar ignition was achieved. Although Jupiter would need to be about 75 times more massive to fuse hydrogen and become a star, its diameter is sufficient, as the smallest red dwarf may be only slightly larger in radius than Saturn. Jupiter radiates more heat than it receives through solar radiation, due to the Kelvin-Helmholtz mechanism within its contracting interior. U-230, U-200. This process causes Jupiter to shrink by about 1 mm, 0.039 in per year. At the time of its formation, Jupiter was hotter and was about twice its current diameter.